Okay, good morning, everybody, and welcome to today's webinar. Today we're going to be discussing control and moisture ingress to help mitigate CUI. This is our third in our series of webinars. The first one we did was speaking of contact-free installation systems. The second was not all inspection ports are created equally. And we'd like to thank everyone who attended those two webinars. We had a fantastic attendance and lots of positive actions afterwards. So thank you very much. And then, yeah, as I said, today we're going to be discussing how to control moisture ingress into your installation systems to help mitigate CUI. So my name is Karl Metcalf. I'm VP of Business Development here at Integrity Products. Just got my 4-year anniversary here at Integrity, so that's fantastic, and thanks to all the Integrity team. So combined, I have about 18 years of experience in the construction and oil and gas industry. Joining me here today is my colleague Ahmad, as always. Ahmad, say good morning.
Yeah, good morning, everyone. Thanks, Carl. Hi, everyone. This is Ahmad Rana. I'm Technology Commercialization Director with Team Integrity. And I have a master's degree in materials and corrosion engineering from Dalhousie University. And I have 10 years experience carrying out field inspections, asset integrity, as well as R&D functions.
Great. So on today's agenda then, we're going to be discussing CUI and damage mechanisms, moisture ingress points and sources of moisture, terminal cycling implications, moisture barrier products that we have, some additional products that Integrity Products carry as well. We'll do a quick summary, and then we'll leave it open for some questions then towards the end.
Okay, so as we can see on the screen, so there are a bunch of listed damage mechanism. So as the name of this, the presentation indicates that the control moisture ingress mitigates CUI. So that is basically the correlation between the moisture and CUI. So first we need to know what is CUI. CUI is corrosion under insulation. So this is one of the damage mechanism among 70 damage mechanism that has been reported by American Petroleum Institute. And like other members of the corrosion family, so CUI also needs moisture for its occurrence. And when we say about the CUI, so it's a very well-known damage mechanism across the industry. And it's being reported that 40 to 60% failure in the piping system is because of the CUI. And when we try to specify the pipe size with CUI, so it's being reported that the piping with diameter of 4 inch and less, they are more prone. That means they are 81% more sensitive towards CUI in terms of the failure. And in terms of the maintenance budget, 10% of the maintenance budget spending is related to the damages from CUI. And when we try to say that what is the probability, consequence, or the quantification of CUI, so there are multiple factors that actually influence CUI in terms of the design, type of insulation, condition of insulation, and also the surrounding conditions and the various equipment and interface factors. So when we say about the design, so we should be able to see whether the system, the system is designed in a way it should be able to stop the moisture ingress in that scenario, which the design should be capable. And also the insulation should be itself that should be stopping the moisture intrusion, or if the moisture goes into the system, into the insulation, it should be able to let it out of the system. So that should be the mindset with the selection of insulation. And when we say about the surrounding conditions, so surroundings like marine location, the proximity to the river, and all these the moisture factors, these are all the surrounding conditions that actually drive govern the possibility of CUI.
Yeah, so one of the standards we'd like to speak to is the NACE SP198, which states that carbon steel corrodes not because it is insulated, but it is contacted by aerated water. And some of the mechanisms we see here for moisture ingress can be Specifically, we get a lot of, especially NDT contractors and technicians, speaking about finding corrosion right where they're doing their test, because the inspection port which they're using has been allowing moisture ingress. So it's not giving you a proper look at the condition of the pipe. Also, then we can see from some of these photos here that obviously mechanical damage on the cladding itself is a huge moisture ingress point. Any sort of protrusion, jacketing laps, I know in definitely Ahmad as well, and some recent projects that we've contacted with, the jacketing laps seem to be getting more and more, like up to 4 or 6 inches on your jacketing lap.
Exactly.
The jacketing can be damaged quite easily. You can see here in these photos as well, like the bevels can sometimes get beat up when they're cracking those flanges. And all this can lead to the insulation underneath getting soaked. Also, these are some recent photos that we took from a project that we were working on in northern Alberta. So you can see on the left-hand side here, some trees have fallen onto the pipeline, resulting in damage to the outer cladding. And then we also have this bear who we've seen walking along the line and just crushing the cladding as he goes. So it's not always down to bad workmanship or people stepping on the lines or any other sort of damage like that. Sometimes it's just, as I say here, the interaction with nature and how that can also damage your cladding system.
Awesome. I would say it's a warm and cozy location for the bear in the
especially in wintertime in Alberta. Yeah. The bears like to get up on those warm pipes for sure.
Most attractive, yeah. Okay, so when we speak about the surroundings or the neighborhoods, so the main thing that comes from the surrounding is the moisture. And the various sources, external sources of the moisture could be the rain, thunderstorms, floods, snow, all these contribute towards moisture or the relative humidity. And also in the dry locations or the locations that are not in the proximity to the oceans. So still those locations could be having the high humidity, those plant locations, because of the cooling tower drift or the air that is coming from the cooling towers that carry the moisture. And the moisture, not only it carries the moisture, but the moisture carries the chloride ions in that. So in that scenario, there is a high possibility for the CUI as well as the chloride stress corrosion cracking. And also there have been various instances where the process spills or the leaking flange from some equipment or some pipeline that triggers the CUI in one of the neighboring line. And also like from some of the neighborhood maintenance activity, like there is a hydroblast cleaning of exchangers or the pressure vessels. So the moisture or the water that is coming from those maintenance works, that can also trigger the CUI via soaking of insulation. And also like the areas where there is a consistent pouring of the salt on the roads, especially during the winter time, and whenever there is a rain, there is a high possibility that the vapors or the envelope that will form around the insulated lines, that would be a high chloride vapor envelope. So these are all the factors that contribute that, and I would say these are all force majeures. We can't actually do anything about that except controlling the process spills and the neighborhood leaks. And when we say about the internal sources of the moisture, so internal sources could be the damage of the pipeline or the pressure vessel itself, like in the form of like a pinhole, or there is a rupture, there is a fracture, or the complete failure of equipment. So this result in the loss of containment and the release of the moisture. And also steam tracing, that is on the line to maintain the temperature, that can also get damaged and cause the condensation or the moisture build up on the pipe skin. And also the condensation and the thermal cycling, these are really concerned, especially they can damage the passive scales that actually form on the metal skins and aggravate the CUI rate. So as I just mentioned about the thermal cycling, what it does actually. So thermal cycling, it is reported in the literature that temperature is one of the major factor behind CUI, and the cyclic temperature or the thermal cycling that accelerates the corrosion rate, CUI rate. And also CUI strongly accelerates, another paper says CUI is strongly accelerated by the temperature fluctuations. So here is the picture on the right side. We can see that the coating that is being damaged via cracking and spalling. So what it does, like what happens during the thermal cycling, whenever there is a consistent expansion and contraction of the metals because of the temperature fluctuations, so the coatings or the any protective oxide scales, they can easily get destroyed during that thermal cycling process. And the destroyed coating in the scales, that is again high, that again triggers the corrosion. So this is how it works. And as the name of the slide indicates, the presentation indicates, the control moisture ingress. Why we need to control the moisture ingress? What is the concept of the electrochemistry? How does it say? So normally what happens with the CUI, what it needs for the happening of corrosion or the CUI, we have to have metal, we have to have oxygen and the moisture. So if we eliminate the moisture and if there is only metal and oxygen, so there will be only surface oxidation. So the oxide scale. And oxide scale in most of the cases, it will be passive. And this is one of the things that we shouldn't be concerned about, that as asset integrity or corrosion engineering professionals, they shouldn't be bothered about that. And when we say about the moisture activity, what moisture does? The hydroxyl ions from the moisture or the water droplets, they interact with the iron and they form the iron hydroxide, then they get decomposed into the oxide scale and the moisture again contains dissolved iron ions, and again it triggers the oxide scale formation, and the oxide scale again gets damaged because of thermal cycling or incoming moisture. So this way this reaction continues. And the moisture presence we have to avoid. We have to eliminate the moisture from the system so we can control this second reaction that of a consistent oxide scale formation and the breakage. So not only the moisture is a concern for the metal itself, but also the thermal insulations, Karl, can be easily compromised, and we have seen that, like how the temperatures on the pipe skin is deteriorating, the temperature rating.
Yeah, absolutely. And I think this is a very interesting slide here, Ahmad, where we have learned that something even as low as a 5% moisture content in the insulation can have a significant rise in the K value, up to 25% in the K value. Exactly. So that would significantly affect your thermal performance, and especially depending on the exact circumstance and location and time of year, or where you're going to be installing your insulation. To have just a 5% moisture content of the insulation is very easy. So you could find yourself very quickly having less thermal performance than what you expected.
Exactly, yeah. So, and like sometimes they say that we can increase the thickness of insulation to increase the K, to reduce the K value, but I would say it's not, it won't really help.
Yeah, a more cost-effective way of doing it may be to try to control the moisture ingress into the insulation. Yeah,
exactly. So before I talk about the controlling the moisture ingress via use of the various moisture barrier products, I will just talk briefly about the challenges at the various moisture gateways. As Karl, you mentioned earlier, like the inspection port is one of the moisture gateway, means the point where the moisture can easily intrude into the system. So API 581, that is standard for risk-based inspection. So that says that like the promptly replacing and resealing of the plugs, here it refers the inspection plugs, is imperative. So what is the purpose? So that the moisture can't go into the system. And imagine that if the moisture is going into the system from the location of inspection ports, so we can definitely see more corrosion on the locations of inspection ports. And for me to be an asset owner, I would be really concerned about the quality of the data and the confidence in the numbers that I get from the data.
Yeah, for sure, because it's like you can see here as in the port that's pictured, that the data that you're going to get from this is not representative of the rest of the line, which is the information that you're trying to get this. So even though this inspection port seems to be installed okay, it's got silicone around it, there's still moisture ingress points in those slots and holes around it. So again, it's kind of defeating the purpose of doing your NDT inspections and gaining that kind of quality data that you can rely on.
Exactly. So like I would just take the opportunity to like highlight three main features of the inspection ports. It should be the real representative of the system in terms of the data acquisition. And secondly, it shouldn't be letting the moisture inside, as API 581 says. And third thing, there shouldn't be any thermal loss from the inspection port. That should be the way it is designed and build friendly.
Yeah,
and
yeah, it's another imperative point that the insulation piece or something like our pillows is put back into the cavity so you maintain your insulation values.
Yeah.
And so to address that, we have our integrity plugs. So these are made from a specially formulated silicone rubber. Has an operating temperature of minus 150 Fahrenheit to plus 450 Fahrenheit. And they have a flexible metal skeleton built into the edge trim, which allows them to easily bend and contour to the curvature of the cladding which they're being installed to, or it means they can also be installed on tight elbows. They've got a very low profile design, so that almost the entirety of the plug sits on the outside of the insulation, just on the cladding layer. So they work great with low profile hydrophobic blanket insulations. They have excellent UV and ozone ratings and are built for a 25-year service life. We've a wide range of sizes, going from 2.5 inch to our largest, which is 14 inches by 4.5 inches. Again, that one's kind of great for large bore piping or tanks and vessels, this kind of thing. And they also each plug comes in its own individual package, which contains a cardboard template, so you can easily mark and cut out the hole for installing the plug. They come with the stainless steel screws that are required to install them. They also come with full install instructions, which also contain a QR code, which brings you directly to a installation video. Here are some field shots of the plugs installed. So we can see on the left-hand side, we've got this is one of our 5-inch rounds installed right at a kind of key location there in the piping. And also on the right-hand side, this is our 9.5 by 3.5 inch inspection port, which is installed right on the apex of this tight elbow. Again, Ahmad, I think you're kind of gaining here the maximum access you could expect to gain on this elbow. Exactly. From an inspection port, like without stripping it.
Absolutely.
Gaining the maximum amount of access. So again, very important to the NDT technicians that they can take a good sample size and have data then that's representative of the piping as a whole. The other important feature of our integrity plugs is that because they have the flexible metal skeleton, they will actually bend and again contour to any mechanical damage which they receive and still maintain that watertight seal. So here's just a couple of images showing the rough life these plugs have to put up with in the field, but you can see, particularly with the one in the center, that even though it's received some very heavy mechanical damage, the port still stays sealed and maintains its watertight seal.
Thanks, Carl. So another gateway that has been a concern for the piping, for the insulated piping, are the terminations. Especially, I would say in most of the cases, the terminations are protected via beveled end caps. And there is a likely possibility, as we have seen in the earlier picture, they can easily get damaged due to the mechanical loading and due to the pipe vibrations or the silicone, that sealant that is being applied at the edges, that can easily be compromised during the aging. So once the termination is compromised, either because of mechanical damage or from the damaged silicone, so the moisture can easily intrude into the system. So we have designed this product like the termination gasket that is being tailored to match the size of the various insulation and the various pipe sizes. So that helps to stop the moisture ingress at the terminations. And also another benefit is that it compartmentalizes the moisture. So the benefit of compartmentalization can be used to address this concern, as highlighted by API 571. It says about the sweet spot for CUI. So what it says, the first few feet of a horizontal pipe adjacent to the vertical run, that is the most favorable location for CUI. And imagine why it happens, because the moisture goes down due to gravity, and especially the horizontal segment next to the vertical segment that receives considerable moisture that is coming down. And imagine we have a termination gasket that can stop that moisture transmission via insulation. If we compartmentalize that moisture travel and we do the proper inspection and the maintenance at the same spot, definitely we can eliminate that, the CUI from that loop.
Yeah, for sure. And as you said, Ahmad, moisture is always going to move towards the low point in the system. So we see a lot of clients use our termination gaskets in order to be able to either seal those terminations or compartmentalize their system. Particularly, they might use our drain plugs as well, so that you're given a path for moisture to escape the system. So you're stopping it traveling down your lines, and you're also giving the moisture a path to escape.
Exactly, and this is also made from solid state silicon compound that can fit up, like that can survive up to the temperature, constant temperature of 240, 250 degrees Celsius. And because of the wide range of sizes, and it can match the wide range of thickness of insulation thicknesses, it's a precision fit, and it's very user-friendly in terms of installation. And so there is no need for special workmanship for that. And these are some field shots for the horizontal and the vertical terminations. So all you need for installation, just need to apply the silicone. No need to apply more, I would say.
Yeah, so the termination gasket itself is just kind of open on one side, so allows you to kind of open it and wrap it around the pipe. And it's then just a friction fit, like the cladding comes over top, and one of the standard bands that they use in the industry is just going to be used to kind of to fix it in place. And then, clients again usually just have a bead of silicone around the inside trim, and then it's as simple as that. So a very quick and easy install for a prefabricated termination gasket, which, as I say, will maintain those that watertight seal at your terminations.
Okay, so another concern in terms of the moisture intrusion is the protrusion in the pipes and the vessels itself. So this is like a citation from API 583 that says appurtenances or the protrusion, like in terms of grinnell clamps or the rings and the saddle or the support that actually project outside the insulation. So they create the openings. So those openings are the sweet spot for the moisture ingress, and definitely the CUI can be triggered from those locations. To address this issue of the moisture intrusion at the location of protrusions, we have the clamp covers, and they are made from the EPDM rubber and can sustain up to a temperature of 149 degrees Celsius, constant temperature. They are also made from, they also have a flexible metal skeleton like our integrity plug. They are having the excellent UV resistant, and they are available in range of sizes. So, like, interesting thing about this this plug is that we can stuff that with the insulation. So, and we can avoid the thermal losses from the.
Yeah, absolutely. I think there's a couple of key features. As I said, it has the flexible metal skeleton, so it allows to form a nice seal with the curvature of the cladding itself. Again, we would recommend additional silicone to help seal it, and again, that's part of our install instructions. And then, of course, if you were to kind of just stuff it with insulation, you're kind of also protecting against any thermal loss through the grinnell clamp itself.
Okay, so this is our perforated dimple wrap. So as we know that, like, the sweet spot for the moisture intrusion is via terminations, protrusions at the inspection port. And also there are like many instances the moisture intrudes through the jacketing labs or like any damaged cladding. So in those circumstances, the moisture intrusion rate would be significantly high. And once the moisture goes into the system, so there would be thermal losses because of the soft insulation, and the CUI on the pipe skin because of the moisture activity. So we have this the newly designed product that helps to eliminate the moisture out of the insulation. Even in the insulation is soaked, this is designed to take the moisture against the gravity. So via evaporation. And so how does it work? So basically it's creating a standoff between the jacketing, outside jacketing, and the outside surface of the insulation, but I would say inside surface of the jacketing and the outer surface of insulation around a 6 millimeter standoff. And it has the perforations. That perforations allow the vapors to escape. So I would be able to show in the upcoming slide like how does it like allow the escape of the moisture. So yeah, here is some interesting data. We can talk about that. So this perforated dimple wrap recently we installed at one of the site of a Canadian asset owner, major Canadian asset owner in Western Canada. So we installed the perforated dimple wrap back in October 2019, and that we were given a trial section of a few kilometers, and then we did the data acquisition on a bi-weekly basis.
Yeah, and it was installed over pre-existing wet and damaged insulation.
Exactly.
I think the moisture levels that we measured at the start were upwards of 80%.
Absolutely,
insulation.
Yeah, significantly high. So like, so there was a lot of data acquisition, but I would just try to summarize quickly to give the background of this project.
It's hard to do it in just one or two graphs because there's so much information.
Absolutely, like it took us like 7 months to come up with this conclusion. So basically what we did, we installed the insulation back in October 2019, and we installed the perforated dimple wrap in conjunction with the low point drain, and we installed that with the ventilation windows. We allowed some air to flow into the insulated system, I would say outside of the insulation, so that it can help in drying of the insulation. So we basically used 4 different configurations. The first configuration was only the perforated dimple wrap itself. And the second configuration was the perforated dimple wrap with the vent and drain. And the third thing was the vent and drain only without any perforated dimple wrap. And the fourth configuration was the conventional closed contacting system without any vent and drain or perforated dimple wrap. So all these systems were characterized for the moisture level during the beginning of project. On October 21st, 2019, we had the first moisture reading in the insulation. And we found that like a certain system, I would say the conventional system, okay, here is some. So the system with the dimple wrap, vent and drain. So that was significantly high moisture level right in the beginning, around 75%. And we kept on taking the data on bi-weekly basis. So first I will explain the graph on the right side. So there is a bunch of information.
Yeah, and so, I think one of the things that this graph doesn't explain is that I think initially on installing the perforated dimple wrap, like over a course of 6 weeks, we've seen a significant drop in the moisture content of the insulation. But it also then maintained that all the way till like when we concluded our testing in June. But again, as we're in the Western Canada, we had lots of different days where we had snowfall and stuff like this. So it was able to show us that it consistently was keeping the insulation dry.
Absolutely. And on June 5th, we were able to see like the moisture level was around 1%. So I would say it was almost dry. And unlike the other systems like the conventional and then the system with only vent and drain, although they started as almost dry, but as of June 5th, 2020, and also during the course of testing project, we found that they were having significant moisture. So that was a success story made by the, I would say, perforated dimple wrap. And on the left side, the histogram, we can see that, so this is the average moisture level. So we took the average and we took the absolute values. So even the average moisture level with the dimple wrap, vent and drain, that also reduced significantly over the time. So we also tried to look for how the moisture actually escaped out of the system. So the very first mechanism was the evaporation, and we were able to find the evidence of the evaporation right on the inside of the jacketing. So we installed these inspection plugs at the location we were taking the data, and the time we just opened it, and we just find the moisture right on the inside of the plug. So that was an indicative like the moisture was coming from the inside of the system. And once this evaporation happens, so the moisture tries to find an escape path to go out of the cladding, and if we don't have any mire or any standoff, any low point drain, moisture can stay trapped in the system, and it can go back again in the insulation.
Yeah, and your insulation is going to be in a submerged condition.
Absolutely.
In a lot of scenarios.
Yeah, so we have to have a system in terms of the low point drains and standoff between the jacketing and insulation to allow it to escape. So this is a typical thermograph and how the moisture behaves in the system in terms of the condensation or in terms of the evaporation. So I will just explain this nice looking thermograph. So the red spot is showing the high temperature zone. So this is the hottest zone within the insulated system. So any moisture that was on the surface of the pipe, because of the high temperature, it will evaporate. So once it travels through the thickness of insulation, it's going through the various temperature zones. So the time it will reach the dew point, it will become liquid and try to come down to the 6 o'clock position or the low points. Or it will try to, even if it's a vapor, it will try to go out, and wherever it will find the condensation point, or maybe it can find the jacketing, or it can find the midway through the thickness of insulation, it will liquefy. So the key benefit of our perforated dimple wrap in this case was the moisture that was striking, the condensation vapor that was striking the inside of jacketing, they weren't able to go back into the insulation. They were staying outside. And that's the reason we find the significant moisture with our perforated dimple wrap, significantly low moisture with our perforated dimple wrap.
Yeah, because you're now given the moisture room to move to the 6 o'clock position on the pipe and then freely kind of leave.
Absolutely.
So whether it's vapor or liquid moisture, you've created that 6 millimeter standoff between the insulation and the exterior cladding, which allows that moisture then to leave the system.
Exactly. So I would say in a perfectly designed insulated system, so the condensation is likely expected at the jacketing location. And the presence of the perforated dimple wrap stops the moisture from going back into the system again.
Sure.
So also we had the moisture to escape out of the system via gravity. So the moisture that was condensing at the jacketing, on the inside of the jacketing, that was going down at 6 o'clock position due to the gravity, and it was coming out. And I think we took this picture back in February with minus 35 degrees Celsius.
Yeah, and this was the fantastic thing about doing it in wintertime, was we were left with this physical evidence of icicles grown from the ground up. You can see in the pictures that obviously the warm moisture has been able to exit through our drains, and then as it contacted the ground, it froze and formed these icicles. So as we looked along this piece of pipeline, we could see evidence of our PVC dimple wrap doing its job, getting the moisture out of the insulation and out of the system.
Okay, here is some interesting one. So another benefit of the perforated dimple wrap is that it has a very high compressive strength. So imagine any wildlife walking, any bear jumping on that, though they don't jump on the pipeline. So like they are walking in case of high compressive load. So it can still sustain without damage of jacketing, compromising insulation.
Yeah, I mean, the compressive strength of 39 psi is quite considerable, and really gives the metal cladding that bounce back, from any sort of mechanical damage. And as we discussed earlier, I mean, it can happen in a number of different ways, whether it's a black bear walking on the line or a teddy bear jumping on the line. It gives it that bounce back and that rigidity now to be able to not only protect the cladding, but also then protect the insulation from getting wet.
Yeah, perfect. Okay, so I mentioned earlier about the moisture activity at the pipe skin. So presence of the hydroxyl lines is triggering the corrosion via formation of iron hydroxide, iron oxides, and scales damage and all this chain reaction. So all we need to have is to stop the moisture activity at the pipe skin. So we have this PTFE spacer wrap that is made for high temperature resistant Teflon. Teflon is inherently known to be an insulator, and it has a very high impermeability. So what it does is stops the moisture from reaching the pipe skin, and the event of any chlorides that are either coming from the environment or either coming from the leachant insulation as a leachant. So that can also be protected and prevented from reaching the pipe skin. And
yeah, the other thing the PTFE is doing here is that any moisture formation or condensation on the pipe surface, it now is, it's no longer blocked moving to the 6 o'clock position. So
absolutely,
it's given it that space to be able to move to the 6 o'clock position on the pipe. There's a 6 millimeter standoff, so the moisture is no longer in direct contact with the pipe. And on install of the PTFE, we recommend just a butt finish at the 6 o'clock position, so that moisture can then move into the insulation and from there
Absolutely.
outside of the system itself.
Yeah. And also recently we had a chance to do the field trial for the PTFE. So we installed the wrap, PTFE wrap, spacer wrap on a line that was running at 120 degrees Celsius. The time we installed the PTFE wrap, by taking all the precautions, we installed the PTFE wrap on the line, and we measured the temperature on the outside of PTFE wrap. So it was around 59 degrees Celsius. So that's a fair evidence that PTFE is delivering its insulating performance, because it's stopping the heat from coming out of the system. And as we know that the mineral wool insulations, their performance can definitely be improved if they have the lower incident temperature. So imagine like a insulation that is exposed to 200 degrees Celsius. Having PTFE wrap, Karl, we can bring the temperature down to.
Yeah, for sure. So it's acting as a heat shield for the insulation material itself. And of course, keeping your insulation in good condition just ensures that you get peak performance from the insulation material.
Yeah, exactly. So with this one, it's providing a contact-free design, it's adding to thermal performance, and it's a completely impermeable, anti-leachant, I would say, barrier. And here is our complete system, employing the perforated dimple wrap, PTFE spacer wrap, in conjunction with the vent and drain. So low point drain are meant to drain the accumulated moisture at 6 o'clock position. Vents are meant to allow the air circulation into the system so that like the insulation drying time can be reduced. And the PTFE spacer wrap is helping as a last line of defense and stopping the moisture activity, chloride activity, and adding to thermal value of insulation.
Yeah, and it's been great to get our full system in use on a large scale project, because these are products that we have been working very hard on over the last kind of 12 months. And we've done a number of projects with them, but we recently, been successful getting onto a large scale project. So it was fantastic to see that happening as well. Some of the other products which Integrity Products offers are integrity water indicators. We have a number of ways of doing insulation standoffs. So we've got a silicone and a polyphenylene sulfate insulation standoffs. Of course, we have our integrity drain plugs. And we also have our integrity fire plugs. And many of these products will be of the topic in upcoming webinars.
Awesome.
Yeah, so just in summary then, Ahmad, I think we've discussed everything we wanted to. We talked about CUI and some of the damage mechanisms. We looked at moisture ingress and the sources of moisture, the implications of thermal cycling, our moisture barrier products, and we just done a quick recap of the other products which we offer. So I think now we can leave the floor open for some questions. And I know that we already have a couple that have jumped in here throughout our presentation. So Ahmad, one of the first questions I see here is in regards to our PTFE versus our coatings. So this was a question that came in actually yesterday evening, somebody preparing for our webinar. So they were asking about the PTFE versus actually applying a coating, and what are the differences or the advantages of using the PTFE spacer wrap over just having a coating on the pipe.
Yeah, well, coating, although that is known to be a very good last line of defense, but even with the coating, we cannot, I would say, undermine the importance of contact-free systems. Even with the coatings, we have to have a contact-free system so that the soft insulations can be kept away from the coating.
Yeah, you still don't want soaked insulation in direct contact with your coating system.
Absolutely.
Yeah.
So, and also like with the coating, there are like variety of coatings available for the variety of materials. But the key benefit with the PTFE, I see, is that like it can suit the variety of materials regardless of their metallurgy. So carbon steel, alloy steel, stainless steel, whatever we have, and for the range of temperatures up to 260 degrees Celsius, it can be retrofitted for those applications. And in terms of the installation, I would say it's easy peasy in terms of that. We don't need any surface preparation. We don't need any abrasive blasting or the curing time or after installation, some, like 3-core or multi-core system. There is nothing, that sort of requirement. One membrane we can install via high temperature 3M.
Yeah, and I think it's one of the key aspects of actually applying a coating system, that the install is absolutely critical. Like, to get that even surface thickness and the uniform kind of application of it is so important, and can be difficult, especially in a kind of retrofit environment. So I think that's where, again, like where the PTFE is very easy to install. It just comes in a large roll, you cut it to the sizes that you require and just kind of wrap it on the pipe. And you can also gain like a very consistent finish with it. One of the other key aspects, of course, is that the PTFE is not only cheaper on initial install, but going forward throughout the life cycle of the system, it's a cheaper alternative to a coating system as well.
Absolutely. Like the added benefit of thermal performance. With the coating, we normally don't see that. It's adding to the thermal performance of the insulation itself.
Yeah, absolutely. It's certainly another key benefit to it. Yeah. But yeah, thank you for that question. One of the other questions, let's see here. Sorry, one of the other questions we see coming in here. Ahmad, do you want to just read this one?
How recent was the dimple wrap study? Any additional studies, past or future?
So yeah, I think we did mention that we initially started our study towards the end of October 2019. So that was kind of like a full-scale field trial over 2.7 kilometers of 20-inch pipe. We've also done studies with the University of Alberta, so we've got a lot of kind of lab data on it too. And because it's a new product that we've introduced to the industry, and as I mentioned, we have just won our first very large-scale project with this material. We are conducting ongoing field trials and collecting and summarizing all that data to prove the benefits and the use of the product.
What is the main difference between dimple drain wrap and PTFE wrap?
So I think here again, they're just different applications. The PTFE wrap is installed directly on the pipe. It's made from the PTFE for its high temperature resistance, whereas the dimple wrap is made from a relatively low temperature PVC. It goes on the outside of the insulation, and its key attributes are that it's allowing any moisture build up in the insulation, now room to move into the gap that it has created between the insulation and the cladding. That moisture can then can very easily move to the 6 o'clock position where it can drain out of the system. So as I say, we on recent projects, we have people using the full system, use the PTFE to protect the pipe surface, and they're using the perforated dimple wrap to protect the insulation and the cladding system.
Okay, so here is another question. Can dimple drain be applied directly on pipe instead on insulation?
Yes, I suppose it could, depending on the temperatures and the particular kind of the particulars of the application. But yes, of course, it could. If what you're trying to achieve is, again, creating an air gap that will allow moisture to freely get away from the pipe surface. Yes, I think it could be, yeah.
Okay, and how to seal the overlaps of dimple drain wrap?
So the dimple wrap, as I say, it's just creating a standoff between the insulation and the cladding, and there's really no need to overlap it. I think we've seen some people just overlap it just to try and ensure that it kind of stays together, but it's not imperative that it overlaps. So again, we would recommend that even a slight overlap or butt finish is more than enough to maintain that standoff which we're trying to create.
Okay, so can you please explain again how perforated dimple wrap works? So basically, the perforated dimple wrap is actually giving, I would say, guided path to the vapors that are coming out of the insulation. So basically, it's working with the principles of nature, like I would say.
So yes, I think traditionally, Ahmad, if you can imagine a situation where you've got definitely in a cyclic temperature system where your temperatures are fluctuating and you've got condensation built up on the pipe, a lot of the time that moisture and that condensation will vaporize through the body of the insulation. So once it starts to reach the outside of the cladding, what's it going to do? It's going to, when it reaches the cold surface, the cold inner surface of the cladding, it's going to recondensate and form moisture. So again, if the cladding is trapping that moisture in the system, it's going to soak back into the insulation, which will eventually contact the pipe. So what the perforated dimple wrap is doing is creating that standoff between the insulation material itself and the inner surface of the cladding, and moisture can freely pass through the perforated dimple wrap into that air gap that it has created, flow to the 6 o'clock position where it exits the system through our drains.
Exactly. So basically, perforated dimple wrap is sitting in the coolest zone of insulated system. So any liquid moisture that would be there in the coolest zone, that will find an escape, guided escape path to 6 o'clock position. And also there is a question. I would say it's a question. Can we obtain the previous and current recorded webinars? Yeah, we can definitely. We can send them.
Yeah, they're available on our YouTube channel, and we can certainly make them available to everyone here after the presentation. This presentation as well will be available on YouTube later today, I'm sure, and I'm sure it's going to be something that we will also put out there as part of our marketing and our social media pages.
Awesome. So
we had one other person as well asking about determination gaskets and what sizes they're available in. Yeah, I think we may have skipped over it quickly during the presentation, but we make them bespoke. So for every pipe size, every insulation thickness, we can make the gaskets to suit. We've even done some very large ones in excess of 30 inches on 30-inch pipe. And we can make them right from a very small size to a very large size, including for low-profile insulation systems like aerogel blankets. So yeah, I'd say they're made bespoke, and we can make them in any size which is required. Another question here.
Could dimple wrap be used in steel boxes on valve and flanges? Steel boxes are often damaged due to the same reason, like metallic cladding.
Yep. Yeah, so again, I think absolutely, and thank you for the question, Damien, and we can certainly discuss this in a little bit more detail after the presentation here, but yeah, I think there's a number of different applications where the PVC dimple wrap can be used, and as I said, with the compressive strength of it, I think that there's many applications where it would add a lot of value to their systems. We have another question here, Ahmad, which is asking, is there an acceptable level of moisture content for your insulation to have? I mean, the quick answer is no, like it's zero at best. Exactly. But is there any range? Like we've seen that during the presentation, we mentioned that 5% moisture content increases the K value by 25%, which is significant. But is there anywhere in between that's deemed to be an acceptable level of moisture?
Well, I would say there has to be a significant study on that. Yep. It has to be determined by the application to application, case to case.
The manufacturer, the specific insulation.
Exactly, and yeah.
As I say, I think the quick answer is no. Like, no. I mean, really, don't. If you can keep your insulation completely dry, it's going to perform at its peak. And but I think you're right as well, Matt, that there's a lack of data in the industry about that particular question.
Okay, so is dimple drain suitable for use in cold insulation process?
Again, I would say yes, depending on the particular application. I know that the work that we've done to date has all been on warm insulation systems, but that's definitely a question that we can address here and maybe answer with you directly after our webinar today.
Okay. Use of dimple drain wrap will increase the outer diameter of cladding and ultimate cost. How is it cost effective?
I think we've installed the perforated dimple wrap onto existing insulation, and how we've done that was to remove the existing jacketing, which was overlapped, I think 2 or 3 inches, but we removed the existing jacketing, we installed the perforated dimple wrap, and then reused that same cladding to go back over it because it was overlapped, and the PVC dimple wrap is only it's only creating an extra 6 millimeter to the thickness that we've seen that you actually don't have to oversize the cladding in order to use it. And with that question, Ahmad, where we talk about cost effectiveness, we have seen and we've discussed with many clients that the lifespan of their insulation system in some cases is incredibly short. And we've heard instances of particular clients re-insulating a pipe 3 times in 5 years.
Yeah, exactly.
And you know, the metal cladding getting damaged and having to be replaced on an ongoing basis as part of the maintenance program. The PVC perforated dimple wrap is a relatively cheap product, and if it can really have the benefits of extending the lifespan and the life cycle of not only your insulation itself, but the metal cladding as well, which is very susceptible to damage. So in terms of kind of a cost benefit analysis, I think you would find that the PVC
significantly,
absolutely, and would pay for itself in a very, very short period of time.
Absolutely, yeah. And especially with the maintenance jobs, I would say it's super friendly. You don't have to strip off the insulation. Just remove the cladding, apply it directly.
Yeah, again, traditionally, I think a lot of asset owners would, with wet and damaged insulation, they would be removing the insulation and disposing of it, and then reinstalling new insulation. With the perforated dimple wrap, you have the opportunity to save that insulation. We've also been working with a lot of the major insulation manufacturers, and they have confirmed with us that once their insulation is allowed to dry out and get back into good condition, it will retain all its thermal performances as per out of the factory, out of the box, as per new kind of thing. So not only from a environmental standpoint are you doing your piece, you're not disposing of wet and damaged insulation, but for a cost benefit for the asset owner, it can be really significant.
Absolutely. And like it is a complete clear evidence that the insulation that was soaking wet at around 80% moisture, that was almost dry in June. Yeah,
for sure. And I know our study kind of stretched from October 2019 till June 2020, but I think in our initial 4 to 6 weeks of the testing period, we've seen on many of the lines that we were testing, we've seen the moisture content go from above 80% down to below 5%, like in a 4 or 6 week period. Again, the benefits of doing it in Alberta during the wintertime was we were able to see the sheer volume of moisture which was allowed to exit the system, because we're now giving it the room and the means to drain and pool to the 6 o'clock position and then leave the system through our drains. So yeah, absolutely. I think that's about it then, Ahmad, for our questions. So I think we'll start to wrap up here. Again, anyone, if there's any additional questions you want to ask us after the presentation here, we can certainly address those and contact with you directly. Yeah, again, we'd just like to thank everyone for joining us here today. We do have a $100 gift card, which we do at our webinars for people who have attended. So today's lucky winner is Bobby Farrell. So Bobby, we'll be reaching out to you here afterwards to arrange getting that prepaid Visa card to you. And thank you very much for attending and your support here today. On an ongoing basis, as I say, we're quite active on social media. Our LinkedIn and Facebook is where we bring all our latest and greatest information, and also kind of updates on future webinars. I say, please feel free to reach out to us directly if you have any additional questions or would like a copy of today's presentation. As mentioned, later today, it should be available on our YouTube channel as well. So I'd like to direct people there too. And then, yeah, our full contact details are here. We can also be reached through our info line, which is info@integrityproducts.com, which is on our website, www.integrityproducts.com. So I think that concludes us for today's webinar. I'd like to thank everyone again for attending, and we've got a great number of questions. I think we had some good conversation, so we really appreciate that.
Thank you. Thank you, everyone.